Hello and welcome to this tutorial on how to use the 3-in-1 Box Designer application to create customized boxes. My name is Chris, the developer of the 3-in-1 Box Designer. Thank you for your interest in this product. I believe you will find the design experience to be fun, fast, and efficient. So what exactly is the 3-in-1 Box Designer? Well, it's an indirect 3D CAD modeling tool with 2D export to SVG file capability. This SVG file can then be imported into a laser cutter engraver. Box designs are customized by using parameter settings located in the left side menu bar. The 3-in-1 Box Designer script, which you purchased, runs within an open source CAD environment called JSCAD. After purchasing and downloading your zip file, you will need to unzip this file. I'm on a Mac, so I will go ahead and double click on it. If you're on a Windows, you'll need to right mouse button, click, and extract. Inside the zip file are 3 other files, one being the getting started, which is covering the instructions of what I'm talking about right now. And you have the 2 script files are based on the units that you'll be using. So if you're using inches, go ahead and you'll be using that. Or if you prefer millimeters, you will drag and drop that onto the JSCAD website. So to get started, go ahead and navigate. There are 2 different websites you can use. One is hosted on my own server, and that is arbodesignscoapps.com, JSCAD/web/demo HTML. So that is one, and the other one that you can use alternatively is the actual OpenJSCAD website is also available. So you got 2 options there. I will go ahead and select the Arbo Designs web page, and it will load this JSCAD environment, which we talked about in the introduction. So now what we need to do is we need to go ahead and drag. I'm going to work in inches, so I'm going to grab the inches script file, and you need to drag and drop, and there will be a default box here. So that's how you get started. Alright, let's talk about these parameters here on the left side. And we have several different sections here. We have common, lid, laser, finger pole, notch, dividers, view, export. So you can collapse these just by clicking on them. Sometimes it'll clean it up a little bit. But anyways, let's talk about the first section, which is the common. Common to all the different box types. So we've talked about the units being in inches in our case, and that is located up here in the script file that we loaded previously. So the measurement, reference measurement, is the outside. So what it's saying here is this is 4 inches outside, so it'd be 4 inches from the outside of the box here to the outside here. That'd be the width. So the width would be, I like to think of it as if I'm looking at a cabinet, facing a cabinet. I look at the width of the cabinet and the depth going in towards the wall, and then the height of the cabinet. So that's kind of the reference that I used here, which translates to X, Y, and Z as well. So let's take a look at, so yeah, if you're in outside, the references will all be, these numbers will correspond to the outside of the box. So the 6 inches for the width. And if you want to increment or decrement these, you could just go ahead and click on the little button there inside of the edit box. And you can make it taller, make it shorter, wider. So that's how you do that. The material thickness, so since I'll be using this on a laser cutter, 0.125 inches, approximately 1/8 of an inch is the material that I will be using here. And the next is finger joints. So you can turn finger joints off, and these are the finger joints here. And you could turn those off depending on a different use case. If you just want to to have some straight cuts and go ahead and glue or nail them together somehow. So that's an option. And then you have these joints per side here. So you got your front, back, left, right, and you got your height as well. So if I wanted to change the number of joints on the front and back, I could go ahead and click here and increase the number of finger joints, and also the depth going this direction here. I could increase or decrease, and also the height. Let's add a couple more there. That's looking better. Next, let's discuss the lid parameters. So under lid parameters, we have lid type is the first one. So we have 4 different types of lids that we can assign. The default is none. We have finger joint, we got a flip, and a slide top. So default is none, which is just an open top. If you want a finger joint, you can go ahead and create a box like this with the lid on top of it. And now we get into a flip top box, which creates a hinged lid. So here's the little hinge here, it rotates there. So let's go ahead and make this a little bit smaller. Okay, so there's your flip. So over here I have some parameters that are specific to certain types of boxes. In this case, this is a flip top box. So I have these little designators called out for flip. So these parameters are only applicable to a flip top box. So the lid tolerance. So what that is if you look straight down at the box itself, that would be this little border that goes all the way around. So you're going to have like a little gap all the way down here. So that would be the tolerance. So you don't want it to be rubbing right up against the sides. So if you go ahead and increase that, you'll see the gap getting a little bit larger. So it gives you a little more side to side and won't bind. So I've set up some defaults here that should work pretty well for a starter box. Okay, the next flip parameter is the lid hole clearance. So the lid hole this is what I'm calling the lid hole here. So if you just zoom in on this, so you can see the little post sticking out here. So you can increase the tolerance. Say if this was too tight or it's rubbing or binding, this little post is binding here, you can go ahead and increase that a little bit. It'll make the hole a little bit larger. I haven't had a use to or need to do that, so the 0.01 should work in most cases, but if not, there's a parameter to do that. A parameter that I added from a recent version of this was this lid post width offset. So what I was finding is I actually got some feedback from a customer that was making some long boxes out of MDF, and this little hinge post here, this little peg that sticks out, was kind of small, so it wasn't very strong. It didn't have a lot of support. So I've created this width offset so that you could actually make that wider. So it gives it a little more strength. The only drawback to that is the lid will sink down further into the box, but in most cases that should be fine. So that's what this width offset is. So if we set that back, it to 0. If your box is pretty small, I would just leave it at 0. If you're making long boxes, you might want to add that. Okay, and then so those are all the parameters for the flip box. Those three here applicable to the flip. So let's go take a look at the slide box. So the slide box has a lot of different parameters, and what the slide box is, you'll be able to you can grab this little finger pole and you can drag it out, and then it just kind of nestles underneath this lip here, and it keeps the lid from falling out. So you'll see more of that later on. All right, so the side-to-side clearance. So I've set some defaults here of distances. So that's going to determine the snugness of this lid on the side. So let's look at the lid top clearance. So what the lid top clearance is, it is this distance right in here. So as I increase that, you'll see that gets larger. So it stops it from rubbing on the top, as well as the side-to-side clearance, which is going this way. So as I increase that, you'll see that start to grow. So I believe that the defaults from the boxes that I created, this 0.06, works pretty well for keeping it snug enough in there to where it just doesn't come sliding out when you tilt the box. But you can play with it. Those are they got parameters there to play with. Okay, so the other one we have is the corner radius. So you can see that these corners on the top here have a little radius to them. You could increase that if you want. Just click on that, and so it's kind of more of a decorative thing. And the front top support. The front top support is this going across the top. So you see a lot of boxes out on the internet there that have this. It's, to me, it's kind of a decorative thing or just a design choice. So you can turn that on or off. If you don't want that, you can turn that off or leave it on, but we can leave that off. Okay, so if you want to slide this in and out, you have this, what I call a finger pole or a tab. So you can configure it also. Some of the boxes I've seen have a circle, so I've designed that in there. So you could have a circle in there, and you can make the circle larger, smaller. So that way you have a means of pulling that top out. And this, so you go back to tab, and you did the circle, the border thickness. So what I'm calling the border is this little section here that goes all the way around here. That's what I call the border. So if you want to make that a little thicker, you could do something like that, and decrease your radius if you wanted to. You could just make it straight like that. So these are just design possibilities. Okay, then we talked about the finger tab, which is this device right here. So you can make it longer, shorter, or you can make it wider. So there's some possibilities there. All right, the next set of parameters we can discuss are the laser parameters. So these are specific parameters for laser cutting tools. So this is where you could put in your laser curve. So it's good to establish this or come up with a means of identifying what the kerf is for the different types of materials you run, and write those things down. So you want to know that ahead of time. So you just plug your kerf in here, and then that will it'll go ahead and account for the kerf in the final design, so that these joints will fit tight. So you can get a lot of information about the kerf on the internet. And the tab overhang, this was something I designed into this. So depending on whether after the wood is cut by the laser, it'll burn the edges. So if you don't like that, I built this into where, if you look at this, I'll zoom in, and as I increment, you'll see that they stick out. And my intention with this was to allow you to sand those down, so you could actually sand off those burnt edges and get a little more consistency across the finger joints, or just so it doesn't look so laser like, I guess. So anyways, that's a parameter if you ever need to use that, or if you just don't like those burnt edges. There's an opportunity to just stick them out a little bit, take your sander and just sand those down, and just make for a cleaner look. But sometimes it looks cool to have the little brown edges. Kind of almost looks like stitching, but I built that in just in case. All right, the next set of parameters we want to look at are the finger pole notch. So let's go ahead and minimize that. So the finger poles and notches, let me give you an example of what they look like. So if I hit, or I select yes, you can see it does this little scallop thing, and that's what I was calling a finger pole. So it's almost like, if you think of it like if this was a drawer that was slid inside of a box, you would need a means of sticking your finger in there to pull it out. So this is the location. So this is on the front, the back. You can do left, right. You can put them on all sides if you want. And if you want to increase the height a little bit, you could do something like this. You can increase the width, do something like this. So it provides some interesting designs by messing with this. So yeah, give it a shot. It's just a design choice if it's something you want. But if you do put this box inside of another box, which is easy to do with, we talked a little bit about the inside-outside measurements. You can see some of that in my documentation with sleeve boxes, that sort of thing. You could use this to allow you to put your finger in there to pull that out like a regular drawer. All right, let's talk about dividers now. So I've implemented some free-floating dividers. Let's see, you can go ahead and if you want to turn the dividers on, you can just hit yes, and it will set up some dividers based on the number of rows you want and the number of columns. So I think that's pretty self-explanatory. You can go ahead and change that value on the rows and columns. And there is a parameter here called side tolerance. So the side tolerance would be this right here. It'd be the distance in between the inside of the box and the end of the divider. So you can go ahead and increase that. And let me do like 0.125, and then you can see how that pulls away from the side. So in most cases the 0 is all you need, but I did build that in case that was something someone required. And the next one is the top margin percent. So the top margin percent would be from the top here of the box, and it's a percentage from the top of the divider to the top of the box. So let me demonstrate. As I start to increase that, it'll start to move down. So it gives yourself a little buffer from the top of the lid. But in most cases, 0 is fine. And then, let's see here, 3D layout separation. So if you wanted to explode the dividers just to give yourself a visual of what's going on there, they will separate from each other. And if you want to do that. Something else that's very important in regards to dividers, and I know as far as a design perspective, and especially when you're making dividers, you want to understand the dimensions of these inner compartments or cells as you're designing this to fit some component or some part or something like that. So I am limited what I can do in JSCAD. It doesn't have the ability to like show dimensions or anything, but the workaround that I came up with is I'm working in Chrome, but this would be the same for any browser. What you're looking for is the developer tools, and here in Chrome, if I come up to the menu item and you look for tools and developer tools here. So when I click on that, what you're going to look for is you usually have a series of tabs. You want to go to the console. The console is where I can output some items or some value, or in this case, I'm outputting the dimensions of each of these individual cells. So this will be really helpful for when you've got some part that's got a certain size and you want to, is it going to fit in here? So here in the output, the console output, I have the divider cells by width, depth, and height, and in my case I'm in inches. So the width, so if I look down at this, so 1.095, that would be from inside the box to here, and the depth would be from here to there would be 2.813, and the height would be 1.875. So I just wanted to bring this up because it's really important, because especially when you're designing this around whatever you're going to put inside of here, and maybe you want to be tight and you don't want stuff to roll around. So I wanted to bring that up. But I also have not only the cell dimensions, I have the current version of this JSCAD script. So anyways, please remember that. I'll maybe have a separate section that kind of highlights the lesser known features. All right, let's talk about the next section, which is View Export. And this one's probably one of the most useful or most important to navigate through. So the first item we have here is the view. So this is very important, because most of the questions I get are people get stuck with, it's, hey, I need to export this out to SVG, but all I get is STL and JSON, and that is true. That's because there are two views within JSCAD. Here is the 3D modeling view. So with the 3D model, these are the options you have to export what you see here on the screen. So these are mesh type objects that can fit into a 3D printer, and that sort of thing. Now the DXF, it give you weird results. So anyways, just be aware that with the 3D, if you're using this on a laser cutter, this is not what we ultimately want. We don't want to export the 3D model. We only want the SVG. SVG is a two-dimensional sort of space we work in, not the three-dimensional like this. So just if there's anything you take away from this, is understanding that when you get ready to send this out to your laser cutter, you need to kick it over to 2D, and it will flatten your model. And here you can see the representation, and you can spin it around. And if you hit the T as in Tom key, you'll be able to see a top view of this. And at that point, now if you come up here, you will have the SVG option. So that's pretty much all I ever use. Just think SVG for the rest of your life when you work with lasers, and life will be good. So, DXF, you're going to get weird results depending on how it's imported. And so always SVG is what you want if you're on a laser. So anyways, the biggest takeaway is this here: 2D, 3D mesh, 3D printer type stuff. 2D is what you want to export out to your laser cutter. So at this point, once you're at 2D, you can go ahead and select SVG and then export it, and then it will put it out onto your downloads folder, and there's an SVG. So that is the most compatible format you're ever going to find with any vector related program. So SVG, live and die by it. Don't worry about DXF. So I'm sorry, I'm just kind of going off on this, but anyways, 3D, don't export, not going to work. 2D, flatten the model, 2-dimension, export SVG. So that's, just wanted to kind of drill that in, because most of the problems I have, and it's only been a few people, that this is really subtle, and I understand that. And I don't blame those people because it's subtle. It's just a matter of a drop down. So I'll probably create a separate section here within this tutorial, just SVG export, so that it's more clear. So all right, let's go back to the 3D model. The next part of this is I'm going to turn the dividers off right now. So I'm going to turn dividers off. And this part is let's look at 3D, or let's go back to 2D separation. So we go back into 2 dimensions, hit the T key, T as in Tom, to get a top-down view. And if I want to slide this up, I can hold the Shift key down, and on the middle mouse button, I can just I can drag this up side to side. So those are little shortcut keys. You can hold the Shift down and then the middle mouse button to do a panning effect. All right, so 2D layout separation. So all this is going to do, this is the separation here, and you can bring it in or move it out or bring it in. The default should be fine. You just put this in your laser. If it's too close for some reason, if these are you put it in 2D mode and this is like crammed up like this, then you're like, oh boy, I gotta separate that. But sometimes I will use this I will zoom in, and to zoom in, I'm on a Mac. I can hold the Option and just scroll in. So play around with the mouse and holding the Control and the Shift, and you'll get a feel for how you can manipulate this environment as far as the different views and perspectives. All right, the T key. All right, so that's the 2D separation. Let's switch back to the 3D view. And this is what makes this application, or why I wanted to design this, was I love the ability to see a model and rotate it and look at it and see different angles, and before I actually cut this thing. So I know there are a lot of designers out there that you put in parameters and it gives you a flat file like our 2D perspective, but I still can't see or imagine what it's going to look like, and then I end up wasting a lot of material, and it wasn't what I wanted. So this, having 3D, it's not perfect, but you do get a chance to look at it, zoom in, spin it around. And so I wanted even more flexibility with this. Sometimes if you have something inside the box, you want to be able to look inside. So I thought, wow, this would be cool. What I can do is I'll put little check boxes here, and then I can hide certain faces or sides or tops, bottoms. And so that's what these check boxes are. It just gives you a means of being able to look closer into your model and zoom in, or just kind of a little more fine tuning. So what you can do, if you hit the show bottom, it hides the bottom, and show left, hides the left, right, back, front. So that's self-explanatory. You can just turn them all on. Maybe I just want to see this side. So this is super handy. I use it all the time, and just when I'm trying to see what's going on with with my model, and especially if I have dividers in there or if I got a slide lid. I got a lot of components that I need to peel the layers back. It's very handy that way. And let's see, if I turn the dividers back on, I can actually turn those off. And if these next few are for the slide lid, the next three. So if I go back and do a slide lid, as you can see here, and then come back down here, you can hide some of the components here. You can hide this slide lid here, which is pretty cool, and you can see inside you have a couple support pieces of wood here, little side pieces that are cut on the laser. And okay, talking about that, this left and right support, we're calling those the slide lid support, so you can hide that on the left and the right. And so with the slide lid, if I hide the left side, you can see that, oh, I can't see it. So that's the slide lid support that you see there. So to make things even more clear, I've added this is really nice, this 3D layout separation. So now what you can do is you can start blowing this apart. Now you can really get in there and see how this thing goes together. So you'll be using this a lot, and yeah, depending on what values you set, sometimes you want to see, oh, is this going to clear? I don't know, but this gives you a little bit better window into what the final product's going to look like. And let's see, if you do something like this, you can also do your dividers too. You can look at all those, the perspective of those. So it was just a nice thing that I like to build in, develop into this, so that I can, turn my model around, look at it. Before I actually cut it, it's like, oh, is this really what I want? But that's all that was about. Then you can just put it back together. You can put this back to 0. And that's about it for the view export. If you want to export your finished model out to SVG, what you have to do is come over to the View Export section, and you're going from 3D and you want to kick it over to 2D. Okay, then it's going to flatten the model into a two-dimensional space. And at this point, you can just go ahead and come up here to the top and hit SVG and export, and you will have an SVG. If you would like to know what the individual cell dimensions are within your dividers, what you can do is, I'm working within Chrome, but this would apply to any browser. And what you are looking for is, you want to look for the developer tools. And in my case, I'm working in Chrome, so if I click on the menu and I go down to More Tools and go to Developer Tools, and then in here, there's usually a series of tabs, and the one that you want to find and click on is the console. And I've outputted some information in the console, and one of those outputs is the cell dimensions for each of the cells here. So what we're showing here is the width, depth, and height in inches. So width, depth, and height in inches that'd be the size of each individual cell. So in this case here, the width would be 1.094, and that would be, from here to there be the width. And then the depth would be, so the depth is from here to there would be 2.813, and then the height of the divider is 1.85. If you're interested in running this environment in dark mode, it's very easy to do. Just come up to this little gear icon on the right, and there's quite a few themes. I typically will either work in dark or light, but there's a whole series of different colors you can choose from. But if you want to go to dark mode, just click on dark, hit the icon again, and you're done.